Guys, this is Miss Moreau. I just wanted to tell you how much we miss you right now. All of your teachers at Richland Middle School really wish that we were able to be there with you and to help you go through all of this. So please know that if there's anything that you need, reach out to us. We're here to help you, okay? Now, today's lesson, we're going to talk through a few things, all right? The first thing, we're going to talk about a very important keyword in this unit. One of this word actually means the bottom line of a shape such as a triangle or rectangle. So in this picture here, it is the bottom line right there. And in this picture, it's the bottom line right here. Now, what that would mean is that it is the very like straight line there that is perpendicular to the height. Now, what word would this be? Let me switch it back here. It is base. Okay, so this is the base of your shape. This right here is the base. Okay, now some important things to know about the base is that your base is always perpendicular to the height. So what I mean by that is they would create a right angle there, and we'll see a little bit more of that in just a few minutes. Okay. All right, so the next slide here. Oh, let me clear all my information out of there. All right, so now we're going to learn about a quadrilateral that has two pairs of parallel sides. When I say pairs, this is a pair of sides that are parallel. That means they're always the same distance apart and they'll never ever meet. Now let me switch colors here. And here is another pair of parallel sides. A pair means two. So this side here is parallel to this side. Okay, so what shape would that be? This is actually a parallelogram. Okay, now it can have right angles, but it does not have to. A rectangle is also a parallelogram, and it has right angles. But this one, I always like to think of this as like a little rectangle with attitude. Okay, so it's kind of slanted over to the side a bit. Alrighty, so now we're going to jump right in. Let me clear this out again. I want you to estimate and see if we can guess how many square units, what is the area that we think this is going to be. Now, we have not been given a formula for this yet, so we're going to have to just count the squares in here, okay? And I'm going to help you out a little. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Sorry about that sound. 15, 16, 17, 18, 19, 20, 21. Ooh, we have some little pieces over here and over here. So we have some little partial pieces. So we think our numbers should be a little bit bigger than 21. Okay. Now I'm going to turn on a little video that's going to walk you through this. And there'll be some parts where we pause and you get some questions. Let me switch over here and clear out everything that I wrote. All right. So now I'm going to move my camera and I'm going to play this video for you, okay? There we go.
Finding the area of a parallelogram. This is a parallelogram, so is this. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. It looks a bit like a rectangle that's been nudged over. How can we find the area of a parallelogram? Well, don't be put off by the sloping sides, because here's a way of thinking that's going to help you. If I cut a triangle off this side and move it over to this side, we get a form that is so much easier to work with. I didn't take anything away. The entire area of the shape is still there. I just rearranged it to form a rectangle. And you know how to find the area of a rectangle, length times width. But for a parallelogram, we say the area is base times height. When we have to find the area of a parallelogram, we think of it like a rectangle, like I just showed you. A rectangle has right-angled corners, so we have to form a right angle. We find the base, here it's 8 centimeters, and then we run a perpendicular line off the base to get the height. The height forms a right angle with the base, just like the right-angled corners of a rectangle. That is a key point to remember. So here's our height. It's 4 centimeters. Now we have measurements on two sides that meet at a right angle, so we're ready to go. The area of a parallelogram is base times height. So 8 times 4 is 32 centimeters squared. Never forget units of measurement squared. What about this parallelogram? Here's the base, 6 meters. Here's the height, 9 meters. It doesn't matter where the height line is shown. It's always the same height because these two lines are parallel, the same distance apart. Therefore, the height will be the same. The height is at right angles to the base, and that's all that counts. So, base times height. 6 times 9 is 54 meters squared. What if the parallelogram looks like this? This time, the base measurement is on the side, and the height seems to be going horizontally. What's up with that? Guess what? It doesn't matter. As long as you are forming a right angle with the base and a height, you're good to go. This is the same as this. It's just an image that has been rotated. Don't let it stump you. Okay, so our base measures 5 centimeters and our height is 3 centimeters. Area is base times height, so 5 times 3 is 15 centimeters squared. Right, now you're primed and ready. You need to practice some for yourself.
All right, so we are going to actually practice a little bit. Let me get my camera back up here for you. All right, so we are going to go back to that problem that we saw a second ago and learn how to use that formula, okay? So we said that the area, oh, I threw my pen down, sorry. My area equals base times height. Sorry, I'm writing on my screen as we're going, so I don't need to move it too much. So what I need to know is my base here. And I know a lot of people have been having trouble with counting the spaces. And I noticed that with the area of rectangles activity this week. So when we're counting, we have to count the distance from here to here. How many spaces are in there? Now, a lot of people are actually starting here and counting 1, 2, 3, and they're counting where all the lines are. But be careful, you want to know the spaces, how many units there are between the two corners. So like here's 1 space, 2, 3, 4, 5, 6, 7, and 8. We'll call that 8 there. Okay, so this unit, the base of it is 8 units here. Now, we don't know what the units are, so we can call it units. Now, my height, we can never ever measure this right here. This is not the height. Think about it. If you're standing up against a wall, you are nice and tall. I'm 5 feet 5 inches tall. But if I lean way over and slant myself on the wall, I'm not going to be as tall. So your height is always got to be straight up and down. And think about when you go to the doctor, and the doctor always says, stand up nice and tall to measure how tall you are. Well, that's why we need you to be nice and tall. I think it's starting to rain out here. Okay, so my height here in this problem, I'm going to change colors on my pen so we can differentiate a little bit of the writing here. We're going to go straight up and down. So it's going to be 1, 2, 3 units tall. So 8 times 3 would be 24. And that's pretty great because we thought it would be about 21 or a little bit more. So base times height is 24. It'd be units squared. Okay? All right, so great job with that one. You are going to get to practice some now and practice using these rules. Okay, so you're going to try a few examples here. This one, first thing I want you to do is name your shape. Okay, just like we did with our rectangles, we're going to keep following this same set of rules here. So my shape is a parallelogram. Okay, the formula for the area of a parallelogram is always base times height. So my dimensions here, I'm going to make sure I have a pen here. my dimensions, my base will be 10 units. Okay, I'm going to switch colors and put my height here in a different color. My height is straight up and down. You notice it is perpendicular here. It's 5. The only thing I might need that 6 for is if I wanted to find the perimeter and I would add up all the sides. So in that case, I would use the 6 instead of the 5. But right now, it is important that we are only using the 10 and the 5. So base times height. So my formula is base times height. And I'll substitute them in. Base is 10. Height is 5. 10 times 5 is 50 inches squared. Okay? All right. I'm going to clear all this out. And you are solving these as you're working through on your paper as well. Oh, this one might be a little bit tougher. I'm going to move my camera down here for you. All right, so let's, I know it might be a little bit small on some of your screens, and that's okay. I'm going to help you out a little. Okay, my heights. Let's start with the height straight up and down here. 1, 2, 3, 4, 5, 6, 7. That looks like 7 units. My heights would be 7 units. My base. Now, I could measure across here for the base or up here because they are the same thing. They're congruent and they're parallel. So that means the bottom base and the top base are exactly the same in this shape. So it doesn't matter which one you use. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 units across. I'm going to not count that right there because this one cut off. Okay, so we're going to say this is 13 units. My base then would be 13 units. So to find the area of my parallelogram, I would multiply base times height. Okay? All right, so now the rest of these you're going to do, but you'll be answering them within your Edpuzzle, okay? Here is a parallelogram. First thing you'll do is identify the base. And then you'll identify the height. All right, so once you know your formula is base times height, you would multiply them. All right, one more here. Same thing. What is the area of this parallelogram? You know, one of the things that's really cool about parallelograms, I love that demonstration. And if you want to try it sometime, just take a piece of paper, make a rectangle out of it. Okay, here, I'll draw it for you. Just make a rectangle and then cut off a triangle out of one end of it. Okay, so here's my little rectangle this way. Okay, so then just take your pencil and go to a corner and just cut it off. Right there, cut that piece off and then move it over here and attach it to this side. Sorry, I'm looking backwards here. Move it over here and attach it and it'll work. It will make a parallelogram and you will see that it takes up the exact same amount of space because we didn't actually take anything away. We just moved a part of it somewhere else. Okay? And is that the end of them? That is the last problem that we have. So hopefully this was really useful for you, okay? Have a great day, guys.